right, IM3 classes. Today we are going to be getting into the unit circle. First, we're going to do trigonometric functions of any angle, and then the unit circle. There's actually going to be a couple videos for this. I already recorded a unit circle video from previous years, so this is just going to be introducing trigonometric functions of any angle based on finding it in a circle. The general definition of the trigonometric function. So let theta be an angle in standard position. We talked about standard position with our lessons yesterday. Then let x and y be the point where the terminal side of theta intersects the circle x squared plus y squared equals r squared. 6 trigonometric functions. We are only doing 3. When you get into pre-calculus, you will do 6. So we have sine, cosine, tangent, then there's secant, cosecant, and cotangent. We are only doing, we're just going to do the 3 that we've been doing with the SOHCAHTOA. All right. So here, if we have a theta of any angle, and we use the point on a circle. So we're doing a circle here. It makes an angle. Point on the circle. What we need to remember is the x and y. So this part here, this is going to be, let me back up. We have a right triangle. We are dealing with right triangles. So this is all just right triangle trigonometry. So we highlight the right triangle that we're dealing with here. All right. So we have this leg. The value of that is going to be whatever the x coordinate is, right, of this point. So we have the point here. The x coordinate of that point is going to be the distance of that leg. The y coordinate is going to be the distance of the vertical leg. And then to find the hypotenuse, we need to do, we need to do Pythagorean theorem. All right, that's what x squared plus y squared equals r squared. That's just Pythagorean theorem. So what we need to remember, the y sine of theta is y over r, or from what we've been doing, it's opposite over hypotenuse, right? Cosine of theta is going to be x over r. It's always going to be the x coordinate over the radius, or that's always going to be the adjacent over the hypotenuse. And then tangent of theta is y over x. That's opposite. It's always going to be the opposite over the adjacent. All right, so let's look at an example here. So we have let 4,3 be a point on terminal side of an angle in standard position. Evaluate the 6. Again, we are just doing 3 trigonometric functions of theta. So we don't know what theta is, but we're just going to find what those ratios are. So this triangle here, right, the x is -4, the y is 3. We need to find the radius. So it's going to be x squared plus y squared is equal to r squared. X is -4, y is +3. Looking for r squared. That's going to be 16 plus 9 is equal to r squared. 16 plus 9 is 25. Equal to r squared, and then the last step is to square root both sides. The root and the power cancel each other out. Square root of 25 is 5. So the radius of this is 5. So sine of theta is going to be opposite, and it's always this as a reference angle, even though it's theta, but it's y over the radius. So it's going to be, what the heck? I'm trying to write a 3 and it skips on me. So sine of theta is going to be opposite over hypotenuse, or y over radius. Cosine of theta is always going to be x, or the adjacent over the radius, and the tangent is going to be opposite over adjacent. Notice how we have negatives. We're going to be dealing with negatives and the trig functions. That's okay. But there we go. The angle when we're doing opposite, if you're thinking opposite and adjacent, it's always the angle in here you'd put your eyeball at what's that, the angle. Man, this is really doesn't want to work with me. You put the eyeball at the wherever the origin's at, and then you would base it off of that. The radius is always going to be the hypotenuse, but then if it's that way, radius is always hypotenuse, opposite is always y, adjacent is always x. All right. Next one, so let's just do this real quick. So here we have our right triangle right in here. So this is the x coordinate is 3, the y coordinate is -3. We need to find the radius. So that's using Pythagorean theorem, x squared equals y squared, or plus y squared equals r squared. If you're paying attention, you should be able to do this one in your head without doing this, doing the Pythagorean theorem here. But we're going to go ahead, put it all in here. So it's 3 squared plus 2 squared. So 3 squared is 9. -3 squared is 9. 9 plus 9 is 18. Square root both sides. Square root of 18, right? That we do need a buddy system on that. So 18 is 2 times 9. 9 is 3 times 3. So we have a pair of 3s. So this is a 3 root 2. And that should have been, since the side lengths are the same, I mean, one's negative, but you should have been able to recognize the 45, 45, 90 triangle. If not, that's why we have Pythagorean theorem. No big deal. But from here, sine of theta, again, this is our reference angle. The y coordinate is always the opposite side. The x, that's always the adjacent, and this is always the hypotenuse. So sine of theta is opposite over hypotenuse, or y over x. So it'll be -3 over 3 root 2. And if we cancel that out, right, we get -1 over root 2. Then we have, nope, not cosine. We got tangent. Screw that up. I'm going to write it over here. Cosine of theta is going to be x over the hypotenuse, or adjacent over hypotenuse. That's 3 over 3 root 2. Again, the 3's cancel out, so you get 1 over root 2. And then tangent is going to be opposite. -3 over 3 is equal to -1. There we go. And that will do it for this. The assignment, we are doing a quick book assignment. And then we will talk about unit circle in the next lesson. See you guys then.